So in the last video we looked at how the metallic oxides were ionic and were bases. So remembering we had ionic and they were basic. Remembering that what we said was that the oxide ion in those was able to react with the water to create hydroxide ions. They were basic. That was what we were talking about in the last video. So what we're going to do now is show how they react then with acids to form a salt and water. Now remembering that these are fairly straightforward metallic oxides, and a salt is defined as when the H plus of an acid is replaced by the metal. So this is a very straightforward introduction to chemistry type reaction. We've got our sodium oxide. Let's just actually colour code this. So we've got our sodium oxide, which is acting as our base. So we'll do bases in blue because bases in turn indicate as blue or purple, remembering that sodium oxide is Na2O. And then we've got our acid, which is sulfuric acid here, H2SO4. So remembering this is acting as a base and it's going to react with an acid and we're going to create the salt. So remembering that the H plus ions of the acid, so there's two of them, so that's the sulfate ion is 2 minus, it's going to be replaced by the metal ion. Now sodium's a 1 plus, same as hydrogen ions, so they're going to get replaced in a similar way, and then we're going to form water. Okay, so there's our salt, and we just need to balance our equation. So just pause the video and check your balancing. You'll see that that was balanced anyway. Then let's have a look at our next one. We got magnesium oxide. So Mg is in group 2, so we get MgO. And then our acid being hydrochloric acid, HCl. And so if we have a look, we've got our base, our metal oxide is acting as our base, and we've got our sulfuric acid, as hydrochloric acid, acting as an acid. And we're going to replace the hydrogen ions of hydrochloric acid, I mean, give us chloride ions, with the metal. Now the metal here is magnesium, which is a 2 plus ion, so in order to balance that we're going to need 2 chloride ions, and then we'll get our water. This is our salt, and so to balance our equation we need to put a 2 in front of here. So straightforward, the metal oxides are acting as the base, and then they react with acids. Now the covalent oxides, remembering that the covalent oxides are acidic, so what we need to remember now, and maybe you could write this on the front of the pack, is what, if they're the acids, then we haven't got any hydrogen ions to replace to form our salt. So our salt would be a little bit different in that we haven't got any hydrogen ions to replace. So on the front of our pack it might be worth writing down what our anion looks like, because we can't see our anion, our negative ion, because we don't have those hydrogens to remove to figure it out. So if we go to the front of the pack, and on the front of the pack we could write to ourselves, well, the SiO2, so this is our acidic oxide, and its anion, the thing it forms in its salt, what would its anion be? So SiO2 becomes, so SiO2, if you think about where Si is in the periodic table, it's in group 4. So in my brain I think SiO2, it's kind of like CO2, and CO2 forms carbonate, CO3, 2 minus. This is going to form the same kind of thing, SiO3, 2 minus. That's going to be our anion. Our next acidic oxide is P4O10, and we know that that forms phosphate ions, PO4 3 minus. Our next acidic oxide is SO2, and that forms the sulfate 4 ion, which is the SO3 2 minus ion, and then we've got SO3, which forms SO4 2 minus ions. So we need to remember these acidic oxides and which anion they give us. So try to keep those in mind, and we'll go back to our page. So this time our silicon oxide is our acid, so SiO2 is our acid, and sodium hydroxide is our base. So they are going to form salts. So this is now our acid and this is our base, and we are going to form a salt. And the salt always contains the metal from the base, so sodium, and then it's going to contain the anion from the acid. So if you go back to your front page and you look, what does SiO2 produce? SiO2 produces SiO3, but remembering that this is a 2-, and therefore it needs 2 sodiums to balance it. And this particular salt is called sodium from the metal and silicate from the silicon oxide ion, and then we've got water. And now we just need to balance our equation. We just need to put a 2 here. So let's have a look at our next one. Phosphorus 4 oxide is our acid. Sodium hydroxide again is our base. So here's our acid. Here's our base. Remembering that we're going to use the acid to make the anion, so PO4, remember that's 3-, and our base is going to give us our metal, and so we're going to need 3 sodiums to balance PO4 3-. That's going to be our salt, and then we're going to add water, and this salt is going to be called sodium phosphate. And then we balance our equations. Now, phosphorus equations are always big number balancing because of the P4. So we're going to end up putting a 4 in front of the sodium phosphate, which means we need 12 sodium hydroxides, which means we need 6 waters. And we've got our sulfur 4 being the SO2, so 2 oxygens to balance the 4, that's our acid. And we're going to go with sodium hydroxide again, it's our base. So we've got our acid and our base. And remembering that our acid is going to give us the anion, the negative ion, so the SO3, if we look back at the front, and that's a 2-. And so it's going to need 2 sodiums to balance it. So that's our salt. So that would be called sodium sulfate. We do need that Roman numeral because there's 2 types of sulfate. So 4, and put H2O. Just check your balancing. We need to put a 2 in front of sodium hydroxide. And that gives, if everything else is balanced. And then we'll do our last one of these. We've got sulfur trioxide as our acid, sodium hydroxide as our base, and then we're going to make our salt. Remembering that our anion is coming from our acid, so SO3 becomes SO4 2-. We're going to need 2 sodiums for that. That's our salt, that's called sodium sulfate 6. And we'll get water as well, and we need to balance that with a 2, and then the rest of it's balanced. Now the last little bit of this is, you'll notice when we were doing the metallic oxides, the ionic ones, we missed out aluminium. And remember earlier in the previous video we said that aluminium was ionic with some covalent character. Well, here we go, aluminium oxide is special. It's this word amphoteric. It can react with both acids and bases. So when aluminium oxide reacts with acid, Al2O3 is the base. And they're the easier type of reaction. When metal oxides act as bases, that's as you would expect. So aluminium oxide is the base, hydrochloric acid is the acid, and we're going to make that salt, remembering that the acid always gives us the anion, so chloride ions, and the base always gives us the metal part, So we're going to go aluminium, but aluminium's a 3+, chloride's a 1-, so we need 3 of those. And then plus our water. So we've got our salt, acid, base, and we just need to balance our equation. So we spend a little bit of time putting in the balancing, and we have our equation. And again, we can repeat that with a different acid. So aluminium oxide is our base. Nitric acid this time is our acid. Remembering that the nitrate ions, NO3, 1-, but aluminium's 3+, so we're going to need 3 nitrate ions to balance an aluminium ion. And then we're going to get the water. So we've got our aluminium oxide acting as a base, HNO3 is our acid, and here's our salt. Now when the reaction with the bases, then Al2O3 is the acid because it's reacting with a base. So here we had aluminium oxide was the base, and now we've got aluminium oxide is the acid. So what anion will aluminium oxide make when it acts as an acid? So we need to go back to our front page and add on our remembering that aluminium is special. Let's get that back into black. Aluminium oxide, what anion does that form? Well, it actually forms this aluminium hydroxide type anion. It's got a 1- charge. It's got 4 OHs in it. So aluminium 3 plus 4 OH-, AlOH4, 1-. So we're going to go back to our page and find where we are. Here we are. So aluminium oxide is going to act as the acid. So that means it's going to form the negative ion part of the salt, and we just added that to our list as AlOH4, and it's got a 1-, so we're going with sodium hydroxide. Didn't want me to do that, did it? And so sodium is the positive ion, sodium's 1+, and this aluminium hydroxide ion is 1-. So we're going like that. And now this equation gets a little bit confusing, and you're kind of going to have to try to remember it, because if you actually try to balance this, you'll find the water ends up on the left-hand side. So I have to put 2 in for the aluminiums, and that gives me 8 oxygens on the right, because there's 4 in this little AlOH4, and we've got 2 in front, so 8. And at the moment, we've only got 3, and then we're going to have to put 2 here for the 2 sodiums, 4, 5. So we need 3 more. So we're going to end up adding 3 waters onto the left. So I'm just going to move this little section a little bit over to give myself a bit more space to write the waters in. To balance this equation, I need 3 waters here. And so I've got my acid, aluminium acid, sodium hydroxide is my base, and here's my salt, sodium aluminate. So it's called sodium aluminate. So how would we know which sort of oxide we had? So we're looking, we've got these sodium oxide, magnesium oxide. How would we know whether we had one of those metal oxides or one of the non-metal oxides? Well, we can just use their acidic or basic nature. So remembering that sodium oxide was an ionic oxide and therefore a base, and phosphorus oxide made phosphoric acid, so it was an acid. So why not, let's just test to see whether they're acids or bases with indicator. But look, these are solids. So the first thing you need to do to be able to use an indicator is to dissolve them in water. So add water to the solids. And you're going to get those reactions that we saw earlier on. And then after we've done that, we're going to add universal indicator to the solutions we've formed. So Na2O will form NaOH, and our universal indicator will turn blue because it was pH 12 to 14, remember? And then P4O10, remember, formed phosphoric acid, forms H3PO4, and universal indicator will turn red. But don't forget to add that water, because if you don't add that water, the universal indicator will do absolutely nothing, because it needs to have a liquid to react on to, solution. Then what about these two, SO2AQ and SO3AQ? So these are aqueous already, but these are both acids, yeah? So these were both acids, but what was different about SO2 and SO3? Well, one was strong and one was weak. So we're going to add our universal indicator to the solution. So we don't need that first step because they're already solutions. SO2 forms H2SO3, which is a weak acid. So pH sort of 3-ish, approximately 3. So the universal indicator turns orange rather than red, whereas SO3 forms H2SO4, which is a strong acid. So pH 0 to 2. So UI turns red. You could use a pH meter here to get more accurate results.